Okay, lesson 11, solving multi-step equations, part 1. So we're learning to solve equations that contain like terms, which we've been working with a lot this week. So it's just adding one more layer on, that are on the same side of the equation. Okay? And we're learning to apply solving equations to perimeter questions. So our big idea is, how do we solve equations when we have multiple variable terms on one side? So if you look at the two sides of your equation here, on this one side I've got 7x and I have negative 2x. Okay, I have 7x and negative 2x. So if I use the highlighter method here, I have 7x's minus 2x's. So really on this same side, on the left side of the equation, how many x's do I have if I combine 7x minus 2x? Anyone know? So I've got 7x's, but I've also got negative 2x's on the same side. So overall, how many x's would I have on just this side only? Okay, we'll write it out. Okay, so let's do the 7x and put the minus 2x beside it, and then just reorganize their order. So that if we go back to what we were doing yesterday, Xander, are you copying it down? What is 7x take away 2x? Anyone? 7x take away 2x? 5x? Minus 3? So just by combining those like terms, now we've turned it into the questions we were working on this morning. Okay? So if you can go straight from here, Zach, if you can go straight from here to here, that's fine. Okay, if you can combine the like terms in your head, but you have to show this step here. If you need to write them out, write them out. Okay? So now we've just made this morning's question. So now it's 5x minus 3 equals 12. Now I start solving the equation. All this first step was simplifying or rewriting the equation so that I could start solving it. Now I'm actually going to start solving it. So if I want to get x by itself, x is only in the one spot. This is the side with x. That's the bottom side. It's telling me what to do. And I use reverse BEDMAS. So what would I do to both sides? Both sides now first. When we're actually solving, it goes to both sides. Anyone? No. Reverse BEDMAS. So I'm going to deal with the minus 3 first by adding 3 to both sides. So you undo adding or subtracting first. And then you're going to get 5x equals 15. And now the 5 is multiplying by the x, so I have to do the opposite inverse operation of multiplying, which is dividing. And then I end up getting x equals 3. 15 divided by 5 is 3. Okay, so we're using the skills we learned yesterday about like terms in our first step to make our equation ready to solve. Okay? Ready to solve for x. So here if we look on this side again, we've got all these terms on one side and just one on the other. Okay? So we want to look and see, do we have like terms then? If we've got all these terms here, are there any like terms? So we look for the x ending and the number endings. And then we have to combine them. We've got 10x plus 9, and those, plus 3, no, my bad, sorry. 10x minus 4x plus 3 plus 9, and then don't forget your other side. That's where my brain was going, to remind you not to forget the other side. and see if you can think about why we're writing it that way. Why are we reorganizing the terms on this side? To make it easier to collect them, right? So 10x minus 4x is 6x's. Positive 3 plus 9 is plus 12. Okay. Subtract 12 on both sides then. Now it looks like this morning's question. So we use reverse BEDMAS. We're going to undo the add 12 to both sides. And then 36 minus 12, 24. Divide both sides by 6. X equals 4. Okay, so the only step we're adding on is we're going to make that one side simplified by collecting like terms. Okay, that's the one step that's different from this morning. Then it turns into an easier question once we've done that. Okay, and the other thing about these ones is we don't have the square roots and the squares and the divided bys. Okay, so if you can just collect those like terms, it turns into our easiest two-step equation. Okay, if you can just collect those like terms, it turns into our easiest form of the two-step equation. So our thinking is, what do we do when we have like terms on the same side of the equals? Collect like terms. So what do you do when you have like terms on the same side of the equal sign? You first have to collect like terms before you start to solve the equation. Okay? Collect like terms, and I can even write first here because it's so important. Collect like terms first. So that's our only new rule from this morning. Collect like terms first. If we can do that, then we've got it. Okay? So some people can just underline and collect them, or highlight and collect them. Other people need to write it out. Doesn't matter. So everyone try the first box one. Okay, and remember, here's my two sides. So collect like terms first. I want to see a line where you show me that you know what the simplified left side is. It might take you 2 steps if you're going to line them up, or 1 step if you're using the highlighting or underlining. You have to do one or the other. Hey. You could hunt good luck and hunter out. Okay. We're just on the first one. Well, after the first 2 rounds. The one layer we've added on now is we're collecting like terms first before we solve it. Okay? Collect like terms first before we solve it. Okay, so I see underlining and highlighting going on, which is making me happy. So people are identifying that 5x and 3x are like terms, and then the plus 3 is by itself. Just make sure that if you're doing the line them up step, you don't forget the equals 75 on the other side. That's a common thing to forget, okay? Because you're so focused on the left side, you forget about the right side. So when you're communicating, if you do the line them up step, make sure you still got the equals 75 there. Remember, the equal sign for an equation is in the middle. There isn't one over here, okay? One equal sign per line is a really good math rule, and in equations, it happens in the middle, okay? So then if you add the 5x and the 3x, you should get 8x plus 3. Don't forget equals 75. So now it turns into a question from this morning. Now you want to solve it. Awesome. So now you're just solving this morning's question. 8 times x plus 3 equals 75. What would x be? what would you do to both sides first based on what we did this morning? -3, good. So there's our zero pair. 8x equals 72. And then we would divide by 8, good. And then we do 72 divided by 8 on our calculator, 9. Okay, give the next 2 a go. Okay, try the next 2. So select the like terms first, then reassess your equation, then solve it.
Sorry, these both x's. And the squares are in numbers. So your 2 x's are together, so it's 4 minus 2.
Okay, so once you've collected your like terms, no matter what your way is, how many people got 2x plus 13 equals 11? 2x plus 13 equals 11. 1? Okay, good. Way to go, Nathan. All right, then what did you do next, Nathan?
Then you add or subtract it.
Good job. And then what's 11 minus 13?
-2.
Yep. And then what did you do?
Divided by 2.
Yep. And then you ended up getting?
-1.
Perfect. Awesome. Okay. All right, try the next one. Yeah. Yeah, sure.
Try to make -10 minus 8 in your calculator again.
Okay, what's the, after you collected like terms, what should you get before you start solving? What should your equation be? Yeah, you got it? What should your equation, what should the next step look like here? 13x minus 18, perfect, equals negative 44. Awesome. Okay? So 10x and 3x is 13x. Careful with your calculator. Negative 8 minus 10 is negative 18. Awesome. Okay? Now it turns into this morning's question. So here's the side with x. We use reverse BEDMAS. Is there any adding or subtracting on the side with x? Yes, there's a subtract 18, so we're going to add 18 to both sides. Okay? Add 18 to both sides. Then 13x equals negative 44 plus 18. Turns out to be negative 26. Yep. Okay, and then we're going to divide both sides by 13. And get negative 2. Okay? All right, I'm going to try the next one on your own. I'll pause it for a second. Someone have the next, what's the collecting like term stuff look like? After you've collected them, what should you have before you start to solve? Anyone get that far? Zach, do you know it? When you subtract 10x minus 12x, what do you get? You don't know? 10x minus 12x? Negative 2x. So on your calculator, Zach, you want to do 10 minus 12. And that gives you the negative 2, and just remember the x. Okay? And then plus 3 plus 8 is positive 11. And now it's turned into this morning's question. Okay? So find your side with x, and undo any adding or subtracting first. Okay? I see the add 11, I'm going to subtract 11 on both sides. Remember, it's negative 2x, dropping that negative is a common error, so make sure you don't forget the negative. 21 minus 11 is 10. Divide by negative 2, and you get x equal to negative 5. Okay? All right, this, Hunter and Brady were discussing this question and saying that some people just like to see their x's on the left side always. Because this is an equal sign, does it matter if I rewrite this question like this? Because the two sides are equal, it doesn't matter which way I want to work with it. So if I say, okay, I want the x's to be on the left side always, I can right at the very beginning turn that around. And I haven't changed anything. Okay? So if that's something that makes me feel more comfortable, having the x's on the left, I can do that. And then if I start underlining, it turns out that every single thing on this side is underlined in the same color, right? Which means that they're already in a row, all the like terms. So I can just use my calculator or my brain and do 10 minus 3 plus 9 and get 15x. Everybody good? And then, so that was just a question from the morning. 15 times x equals 128. So to do the inverse operation of times, you would divide. And then you'll end up getting, did I thank you? 10 minus 3 is 7. Thank you. I was saying it was 6. My bad. Thank you guys. So 16x. So then you would do on your calculator, 128 divided by 16 is 8. So try the next one and try that method of turning it around if that makes it feel better for you. Okay? Since the two sides are equal, it doesn't matter. You can switch the two sides if you want. Oh, thank you very much. Okay, and then if you started underlining, you see we use the same color for all of them again, so we've already got all like terms on the one side. So then I just need to use my calculator. 4 minus 8 is negative 4, plus 6 is 2x. Hands up if you got 2x equals 40. Yeah? Good? 3, 4, 5, okay? And then now it becomes this morning's question, 2 times x is 40. Divide both sides by 2 to undo the times. And we get x equal to 20. Okay, got it. Okay. Okay. Now, why did we learn how to do that? These are the types of questions that you're going to have to answer. I don't know why it does that. There we go. Apply our thinking. The total perimeter of the rectangle is, when you see is, think equals, okay? The total perimeter of the rectangle is or equals 73.5 centimeters, solve for x. Okay? So we're going to start off doing it like we would have done it yesterday by adding up, so P equals, adding up the 4 sides. Zach, can you look up here? Okay, so if I add up these 4 sides, what will I get? Zach, what will I get if I add up these 4 sides? You can add them up. Don't, sure, I know you can add those up.
14.
Yes, 14 x's. Okay, good job. So Zach can add around, which is great. If you can't, then you would line them up and then realize they're all the same. Get them on your calculator and get P is 14x. Okay, which is correct. Now we know the perimeter. This is P because it says the perimeter is 73.5 centimeters. So I use an arrow and I go, I know P is 73.5 and that equals 14x. So I can replace perimeter P with the number 73.5 because it tells me in the question that the perimeter is 73.5 centimeters. Okay? So now the side with x happens to be the right side. It's the bossy side, so it's 14 times x, and I want to undo multiplying by 14. So I'm going to divide by 14. So the value of x is going to turn out to be, so if you do that on my calculator, 73.5 divided by 14 5.25. And then you would just do therefore x equals 5.25, and then use the same units that perimeter was in, centimeters. Okay? So now I know what x is. So if I set the value of x into each side and add them all up, I get 73.5 centimeters. Okay? All right, the next one, similar. The perimeter of the following shape is, so that means equals, perimeter is 57 meters. Determine the value of x. So this time we have a triangle. And to get the perimeter, based on yesterday, we would add the three sides together. Okay? So either add around to get the perimeter or select like terms to get the perimeter. So we gotta get the perimeter first. So here's my first side is x plus 7. Perimeter, I have to add all the sides together. Then I add on the next side. Then I add on the last side. So pretending it's still yesterday's question, just like yesterday, I'm going to try to simplify by collecting the like terms. So I'm going to line them all up. X plus 4x plus 2x. So that takes care of my x's. Plus 7 minus 2 plus 3. Okay, so now I'm going to add my x terms together. Remember, there's a 1 in front of that x. So that's going to give me 7 x's plus 8. So just getting the perimeter, just yesterday's question, you should have got the perimeter was 7x plus 8. Remember that from yesterday? Perimeter is 7x plus 8. We all did well on that question where we had to find the perimeter of a triangle. So the layer we're adding on today is it gives us the perimeter, so we can replace p with 57, and then we make an equation that we can actually solve and get x by itself. So once you sub 57 and see if you can solve the equation to figure out what x would have to be to make the perimeter of 57. So notice the sign for x is, and you want to use reverse that math. Yeah, 8 on both sides. You can't add those because you don't have to ask one. So you have to subtract 8 on both sides. Side of x tells you what to do. Okay? And then still, side of x tells you what to do, so I have to undo multiplying by 7 by dividing by 7. And then 49 divided by 7 is 7. So therefore, the little dots, x equals 7. Okay? Therefore, x equals 7. How am I doing on time? Yep, I'm doing okay. Any questions about that one? Okay. All right, try 3A all on your own. So that'll see if you have understood what we're doing with the perimeter. 3A. I'll pause this. Okay, so I've got lots of people adding all the sides together, which makes me very happy.
Didn't even see it. That's right.
Okay, so all together on the same side, there's 12 x's. Some people got there. 12 x's all together on the same side. Yep. Minus 6. Everybody good? Negative 3 minus 3 is negative 6. So all of that was yesterday's work, showing that you can find the perimeter by collecting like terms. What we're adding on today is now we know the perimeter is that, so we're going to arrow down perimeter is 72. And now we can actually solve for that x that we had there yesterday because they tell us the perimeter. Okay? So this says 12 times the number minus 6 is 72. Find that number. So this bossy side has x. It tells you what to do. Use reverse BEDMAS. 72 plus 6 is 78. Then divide both sides by 12. And you end up getting x to be 6.5. And that's what they asked for. Just put a little therefore up front. And same units, centimeters. Okay? So that type of EQEO question is usually on once a year between the two booklets. Okay? Somewhere, either in multiple choice or a short answer. Figuring out what x is based on the perimeter. Okay? Part B, determine the length and width of the rectangle. So this isn't actually that bad. We just have to pick which one we want to be the length and which one we want to be the width. So if I say the length is 2x, because I chose 2x to be my length, I now have a number right here. So it's kind of like a substitution question, except for x is 6.5 centimeters. Okay? So if length is 2x, I can replace x with 6.5. Now, do a little highlighting here. We figured out in step 1, or part A, that x was 6.5. So the length is going to turn out to be 2 times 6.5, which is 13 centimeters. Okay, so the length is 13 centimeters. 2 times 6.5. Type that in our calculator and get 13. And our width is 4x minus 3. So that's going to be 4, use brackets to replace x with 6.5. And don't forget the minus 3. And now we want to figure out what is 4 times 6.5 minus 3. So we'll do the multiply first. 4 times 6.5 on my calculator. And you get 26. Minus 3. And then 26 minus 3. 23 centimeters. So the width is 23 centimeters. And the length is 13 centimeters. Okay? We've come full circle. We learned substituting on the first day, Monday, and then today we found the perimeter by collecting like terms, solved an equation, and then used substituting to figure out the length and width of the rectangle. That's a lot of progress we've made in a week. So I'm going to stop there because I think some people are a little bit overwhelmed, and you'll have some tutor time now. So I will hand out the practice. You'll just have some time